So I was watching a video, Linus Tech Tips. He was doing a 8K monitor as a window or something, and it made me think, at what point does, do we really not benefit from the pixels anymore? Because for most of us, with a monitor this close to us, you don't really benefit from pixels after a certain resolution. And that's what I want to talk about, as well as the refresh rate or frame rates that you get out of it. Alright, so let's talk about our vision first, because that's what all this is about. Frame rate and resolution sort of benefit two different parts of our vision. So the center of our vision, called the foveal region, is very detail focused, but it doesn't really sense motion very well, whereas the peripheral vision on the sides and top and bottom, outside of the center, obviously, it's very, very good at picking up and sensing motion. Hardly any detail, though, in comparison. So one could say that frame rate benefits the peripheral vision and resolution or detail benefits the foveal region. Now, with that said, resolution itself depends a lot more on the distance that you sit from the screen. So there's a very simple way, or, well, depending on how comfortable you are with numbers, relatively straightforward way of figuring out the ideal resolution, because as you get farther and farther away from a panel, if you have an 8K and a 1080p panel of the same size, and you get far enough away, they will look identical. If you're sitting closer, then obviously you'll benefit more from the 8K panel because you'll be able to see more detail, assuming the content that you're watching is in 8K. Now, as far as the science behind this brings to mind angular resolution of the pupil and the Rayleigh criterion, which together they identify exactly how far apart 2 points of light, or 2 pixels in this case, would have to be for your eye to be able to distinguish them from one another. If they're too close, then they'll look like the same pixel, and then they're indistinguishable. But there's a point where they're just far enough, and you can see them as individuals. And that's what really matters here when we're talking about resolution. So then this leads us to pixel density, and then pixel density can help us find the more appropriate resolution and panel size for our needs. So this is just a bunch of numbers, so I'm going to kind of read it off. The angular resolution of the eye is about 0.02 degrees, which means if you make an angle with the vertex at the pupil, 2 pixels would have to make an angle across the eye of 0.02 degrees, which that 0.02 degrees means that at 1 kilometer away, they would have to be 0.3 meters apart to be distinguished from one another. So if we use this proportion, the 0.3 meters to 1 kilometer away, if we say we're sitting 30 inches from our screen, then 2 pixels would have to be at most 0.009 inches apart, which is 111 pixels per inch. So what you want is just a little bit higher than that, so that it's just barely on the side of the pixels are indistinguishable from one another. At 20 inches, you're looking at just over 167 pixels per inch, and at 40 inches, it's 83 pixels per inch, because you're farther away, so it doesn't have to be as detailed because you can't see that much. Now, with that number, we can go to a site called... So we go here or to a similar site, and we plug in the resolution we want, and we keep changing the diagonal until we get to the PPI that we're looking for. 111. Let's shoot for 111. So 25. Oh, there we go. 25 inch, 2560 by 1080. Now, if you don't want to go through all the math, I've got this chart, and it's showing you common resolutions and the desired pixels per inch with the screen size that would get you closest to that. So then if you're looking for a 4K panel and you sit about 30 inches from your screen, you're going to want something around 39.5 inches. So there's resolution. It's a pretty clear point according to angular resolution, where we actually will not be seeing any more benefit. So if you're familiar with HFR monitors, then you know that our eyes can tell the difference up into the hundreds of frames per second. So there's a legitimate reason for the existence of 240 hertz panels like this one. But the debate over the highest point that we can actually see is, that debate's going to be going for years and years, because our eyes are given information in the real world. They're given information at basically infinity FPS. Now, if we look to VR, though, this is where I'm basing most of my gut feeling. Because our peripheral vision is so much more sensitive to motion, VR has set a 90 FPS minimum for their frame rate because it encompasses our whole vision, and it has to be, the frame rate has to be high enough to convince our peripheral vision that what it's seeing is actually real. So if 90 FPS is enough to convince your peripheral vision that it's real, it's enough to convince your subconscious that what you're seeing is real, then I think that should be enough, because if you were to stop at 60, your peripheral would be seeing that, and at a subconscious level, you would still know this isn't happening. But if you get the frame rate higher, things become more responsive, and your vision and subconscious begin to believe and give in to this immersive experience. But obviously, as I said, there are people who are much more sensitive to frame rate, people who are hardcore, and they need higher refresh rates so they can respond faster to the stimuli in the game. But for just overall general immersion and for the uninitiated in terms of high refresh rate, I think 90 is a really good target to shoot for. Now, the issue then becomes, no monitor has a 90 hertz refresh rate that I know of. I've seen 100, but I've only seen those in ultra wides, and those ones are pretty expensive. So then what do? Well, you just stick with 60, because like this chart that I showed about the resolutions and sitting distance and density and screen sizes, some of these monitors don't exist, but there are some that are relatively close, and that's what this chart is serving as. It's to get you close to that point. And the fact remains that anybody can have fun on whatever hardware they want.